Okay guys, so what is ORAN? Why we need to know about ORAN too much? Why everybody these days know what is ORAN? Okay, so the term itself, if you see, it's saying Open RAN. So we know that a radio access transport network, how it's look like, okay? So, and how the hardware look like. So, if you remember the current scenario, how it's look like, if you see, we have one node B, okay, that is connected to the MME. This is the normal current scenario. But this node B, if you see the Ericsson system, what you have one antenna. Then this antenna is connected to what? Radio unit. And then we have baseband, either 5216, 5212, or if it is Huawei 3900. So this kind of base station that we have baseband. Okay, so the system currently operator has to totally rely on the vendors, okay, like Ericsson, Nokia, and Huawei system. So 4G was mostly like this. So ORAN concept was not that much enforcedly. Most of the operator, they they didn't deploy. So now here you can see the first term, that is called centralized unit. What is CU? The second term, that is called DU, that is called distributed unit. And the third term that we call RU, that is called radio unit. So centralized unit means what? CU support higher layer of protocol stack. So what is protocol stack? So any jobs that we have to do, that will be done by protocol. So we know that LT, we have the protocol like RRC, PDCP, RLC, MAC layer, and you can say that physical layer. In the 5G, we added extra, that is called SDAP, Service Data Adaptation Protocol. So somehow we need to design the hardware so that we can create the interfaces like that. So with the help of this protocol stack, you can see that we can design. So centralized unit, you can say higher layer of protocol. So what are the higher layer of protocols? So RRC and SDAP. So this is your L3 and this is your L2, but for the data. Okay, so RRC basically for the signaling protocol, SDAP for the data purpose that is connected to the core network. So here you can see we need to keep higher layer protocol. So definitely here in the centralized unit, we can see we will keep RRC or some part of PDCP layer. Okay. So CU support higher layer protocol, single CU to is G node B. CU can connect to the multiple DU. So one CU can connect multiple DU, also possible, okay? But one DU cannot connect to the multiple CU. So here you can see that second one is the DU, that is called distributed unit. So lower layer of G node B protocol is that. So definitely here, maybe the MAC layer will come, RLC layer will come, and PDCP lower layer will come. It's depend what kind of configuration they design. The last one, that is called radio unit, RU. So centralized processing higher layer element. So mostly here your physical layer will come. Okay, so one CU to multiple DU. So these are the hardware structure look like in the network. Actually, you can see in the future also. So current BTS architecture, you can see radio unit, baseband I told you, that is called 5216 or 5212, the Ericsson one that they are using, and 3900 maybe Huawei one. So this is the baseband correctly they are using, and that connected to the radio unit. Okay, so here also sometime we call RUS, sometime we call RRU. So whatever the name depend. Okay, and that connected to the core network, 5G core network or 4G core network. So it's a depend. This one, this baseband, if you see, they divided in two part. You can see. So one is called DU and another one is called CU. So DU, I told you, that is called distributed unit, and the CU we call centralized unit. So why we need it? Actually, you have to understand about the 5G concept here. So 3GPP design the hardware. Okay, so 3GPP design the hardware. They design one CU. Okay, that CU connected to the multiple DU. Okay, so they are connected to each other. So radio unit, we can carry the digital radio, fronthaul connectivity, the physical RF interface here. In the DU, we can carry the lower layer of protocol stack like RLC, MAC layer, physical layer part. Okay, so we know that what is RLC, what is MAC layer. So this MAC layer we use for the ARC purpose. RLC we use for the ARC purpose. Also in the RLC, you have three different modes: transparent mode, unacknowledged mode, and the acknowledged mode. Okay, so this we use radio link control and the medium access. So MAC layer is very important protocol stack actually in the 5G. Not only the 5G, LT also, because MAC layer here is generate the transport block, and that transport block go to the physical layer actually. So here MAC layer perform like here also we perform the MAC control element. So inside the MAC control element we have different jobs. Okay, so like we have different LCID, logical channel ID. Okay, so that we perform. So in LT it's a 2 to power 5, it means 32 LCID. In the 5G, we have 64 LCID that we perform. So here you can see they will divide the work actually. So maybe some of the completely keep here MAC layer. Okay, so they can design the network. We can see. So random access also we perform in the MAC layer. Okay, carrier aggregation we perform in the MAC layer. SL activation also we perform in the MAC layer. So these are the things we perform here. So you can see a multiple DU connect to the one CU. So maybe one CU you have, and it will connect to the maybe 80, 90, 100, up to 100 DU, depend upon the configuration. So CU is combination of L2 plus L3. So L2, you know that inside the L2, you can see PDCP layer, RLC layer, MAC layer, SDAP layer, L3, RRC layer. So a CU with multiple DU will support multiple G node being. So DU to radio unit, that we call front haul. CU to DU, this term we call mid haul. So what is front haul actually? Front haul is the new name, you can say that. It's not the 3GPP name. So it's anything. Like in LT, we call CIPRI. Okay. The 5G, we call eCIPRI. Okay. And we have different name, TIP also. So we have different 3 or 4 different name that we call front haul. So front haul is not just a 3GPP standard name. It's a name that defined between DU to radio unit. So that we call front haul. Mid haul, we call centralized unit to DU, that is called mid haul. And from centralized unit to core network, that we call back haul here. So we have 3 different interface here. that we can see. So if you see the mapping ran to the transport network, how it's look like. So this is your end-to-end services. Okay. So this is your service layer, and this is your mobile network where we are connectivity. So 5G core to the centralized unit that we call front haul. So distance between 40 to 200 kilometer. Okay. The it should be 10 to 10 millisecond, less than 10 millisecond time it will take. 400G plus link, it should be fiber line. That L3 connectivity and point to multi-point is possible because it's not just one connectivity, it has multiple connectivity to the core network. Second one, DU to CU, here we call high layer split, that is called mid haul. So here you can see that between one device DU to CU, 10 to 40 kilometer possible. 1 to 2 millisecond it will take time to transmit the message. 100G plus linkage required. L to L2 connectivity, point to multi-point connectivity is required. And the third one, that is called RU to DU, that is called lower layer split. Here we have front haul. So 0 to 10 kilometer. It means the distance between RU to DU, 0 to 10 kilometer possibility. 50 to 200, 100G plus link required. Migrate to the L point to point or point to multi-point is possibility. So this is the transport network mapping that you can see in the network actually. Now we can see the split architecture. So here you can see that you have ORAN proposed concept and the architecture. So this is also, you can say that split RAN concept architecture. So there are total 8 known way to functionality split the RAN, and each one propose splitting the processing so that different part of the protocol stack process on different hardware. So it looks different. So how you can see the next slide here. So here you can see that the same architecture I design. Here you can see. So this is your protocol RRC layer, PDCP layer, high RLC, low RLC, MAC, high MAC. So you can see in this diagram why we required actually. The reason is that a new functional split option in the 5G network or ORAN, the increase in the data rate in the 5G make it impractical to continue with the previous CPRI front haul implementation. Okay, so that we move towards a higher layer split that would relax the latency and the bandwidth requirements. But here you can see that we have fewer processing function that can be centralized. Okay, so here the new functional split architecture take into account technical and the cost effective trade-off between the throughput, latency, functional centralization. So 3GPP announce different architecture. Here you can see that. If you see that, this is the EPC and this is your radio resource. This is your baseband unit. Okay, so 3GPP announce this one actually we can use. This is the CPRI cable. So if you see this one 5G core network, we have centralized unit. So in this centralized unit, we have two protocol stack. One is called RRC, one is called PDCP layer. Okay, now here we can use as a CU or a DU. So we can carry this many also possibility. Okay, so if I go for the option 2, so in option 2 what is happening? In option 2 we have PDCP layer, we have RRC layer, plus we have high RLC also. So high layer split point is possible. So here you can see that that is called F1 interface. Okay, so if you see option 6, so here you have FX interface. So FX means what? It is the notation for the low layer split point for the convenience. So we can cascade the hardware into different function actually. So here you can see that in this one, CUDU option 6 actually. So you have FX. So here you can see that higher layer plus in the radio unit, you can keep this also. Higher physical layer, lower physical layer plus RF. In the option 7, CUDU option, so here you can keep the higher layer as well as lower layer, and in the RU you can keep lower physical plus radio frequency. So this is the interface that you can design actually. You can see that here, this to this, we have back hall, here we have mid hall, here we have front hall. So you can design your hardware according to the requirement. Okay, so as per the vendor, as per the requirement, what kind of, whether they want throughput, what kind of they want latency deployment. So based upon that, they can design their hardware system. Now we will see about architecture view of the ORAN actually. So here you can see, this is the simple architecture of the ORAN. So here what we have guys, here we have first two things, non-RT rig and near RT rig. These two we call RAN intelligence controller. Okay, these two we call RAN intelligence controller. Then what we have, we have OCloud. First understand the terms. What are the terms we have here? Okay, so the first term we have here, the top one, that is called SMO. That is called Service Management and Orchestration Framework. Okay, then we have second one, that is called non-RT rig and near RT rig. Okay, so these two are RAN intelligence controller and they are interconnected with A1 interface. Non-RT means what? ORAN, non-real-time RAN intelligence controller. Okay, so it look like small, but it's a very big actually architecture that you will see later. So this is a logical function within the SMO that drive content carried across A1 interface to the near RT. Okay, so they are connected to each other. Then we have near RT rig. Okay, so it's a near real-time RAN intelligence controller. So it's a logical function that enable real time controller and optimize the RAN elements. Okay, so we can see what are the things we have later. Then we have O2 interface. So your SMO is connected to the O cloud with O2 interface. Okay, then this SMO is connected to ORU, that is called O front haul M plane. And this one is connected to the 5G core network, that is called NG interface. So this O2, A1, O1, these all are open front haul is ORAN defined interface. Because and this hardware is connected to the 5G core network, this is called NG interface. So that is 3GPP defined interface. And the another one that we have interface out of scope, that is called this one. Okay, so here, so now we can see this diagram in the bigger way. So here two interface you have, one is blue, that is called ORAN interface, and another one is the red one, black one, that is called 3GPP interface. So here you can see we have different architecture function. So O2 I told you it's connected to ORU, OCloud. Okay, then non-real-time rig connected to near real-time rig, that is called A1 interface. SMO connected to ORU, that is called O1. So what is this term ORU or this? So first we understand OCloud. So OCloud basically a cloud computing platform that collect the physical infrastructure node that meet the ORAN requirement. Then we have ORU. So what is ORU? So ORU means ORAN distributed ORAN radio unit. Okay, so this is a logical node that hosts lower physical layer and array processing baseband. It means this contain your physical layer, lower physical layer, and array processing. Okay, this is ORU. Then we have ODU. ODU means what? ORAN distributed unit. So again, it's a hardware that contain RLC layer, MAC layer, and high physical layer. Okay, so high physical layer. So this is called ODU. We will see later also. Then we have OCUCP. So what is OCUCP? O means ORAN, CU means central unit, and CP means control plane. So the terms itself, it's a control plane. It means it contain RRC protocol and some part of PDCP protocol. So this contain your PDCP also, because PDCP layer also has a control plane and the PDCP layer also have user plane. So RRC plus PDCP layer will come to this side. Then we have OCUCP. So what does it mean? It means ORAN central unit user plane. Okay, so here what kind of protocol we contain? So here we contain PDCP layer plus STAP layer. Okay, service data adaptation protocol. In the 5G, we added new protocol that is called STAP. Okay, so this protocol. Then here you can see that we have OE node B. Okay, so this is either next generation E node B or the normal E node B, that we can see later actually. Okay, so this is connected to the E2. Then yeah, so these are the here you can see that we have open FHM plane. So this is basically connecting between ODU to ORU. So the management interface controlling the open radio unit generally driven from the ODU. So that interface. So you have two interface here, open front hall CUS plane and open front hall M plane. So that interface we can see. I hope you understand, guys. Any doubt in this architecture? So here in this architecture, what we understand, we have different interfaces. Okay, so like O2 interface, SMO is connected to OCloud, O2 interface. Okay, then rodeo is connected to the open front hall M plane to the SMO. Then this one is connected to the O1 interface. Then this one is connected to the E2 interface. Then these two are very important. Today I'm going to discuss about these two. So here we have A1 interface, non-real-time rig and near real-time rig. So these two are that in what you call, so that. So ORAN has some loops that is called control loops. Okay, so what kind of control loop we have? So the first control loop we have here, that is called non-real time here, non-real time control loop. So here we have one like this interface. The second one that we have, that is called near real time here. And the third one we have, that is called real-time control loops. So we have three different control loop in the ORAN system actually. But today I'm not going to discuss what is this actually. We will discuss in some future classes. Now we will discuss about RIC. What is RIC actually? So RIC means RAN intelligence controller system. So we have two type of RIC. One is called non-real-time RIC and the second one is called near real-time RIC. Okay, so non-real-time RIC means what? So non-real-time RAN intelligence controller is inside the SMO actually, okay, in ORAN architecture, and that provide A1 interface to the near real-time RIC. So these two are connected by A1. So here you can see that RAN intelligence controller contain two things. One is called near RT rig, another one is called non-real RT rig. Okay, and these two are connected via A1 interface. So they enable the policy-driven guidance of the near RT rig application function and support AI and the machine learning workflow. Okay. Now, first understand what are the main goal of this non-RT rig. The primary goal of non-RT rig to support intelligence RAN optimization, providing by policy-based guidance like machine learning model management. It's like you can say that current how we are optimizing the site right now. We are checking the KPI, like we are checking the accessibility degraded or not. We are checking the returnability degraded or not. We are checking throughput degraded or not. This we are doing right now manually. Okay, or Ericsson created some tool. Okay, with that tool, but that is not that much advanced. In future, how this will happen? So we have non-RT rig. Okay, here with the help of some, because we understand the network, we understand the scenario of the customer, so based upon that guidance, so that is called first machine learning model management. Okay, machine learning model management. Second, you can say that AI based. Okay, so it means your non-RT rig can use the data analytics or AI machine learning training interface to determine the RAN optimization action, and that provided to the SMO. Okay, so this is the two things. So here in non-RT rig, we have two functions. The first function that we have, that is called non-RT rig framework, and the second one we call non-RT rig application. This we also call RFs. Okay, so non-RT rig framework function in, it's you can say that it's a internal to the SMO framework that logically connected to the A1 to the RFs. Okay, and what is this RFs? So it's a modular application that leverages the functionality exposed by the non-RT Rig framework to perform the RAN optimization and other function via interfaces that we have A1, O2, O1, R1 interfaces that we can see. Okay, and the second term we have that is called near RT Rig. It also a logical function that enable the near real-time control and optimization of the E2 nodes function resources via fine-grained data collection from the network. Okay, so where it's look like near real-time controller. So here, this is. It connected to the non-real-time rig via A1 interface. Okay, it connected to the OCUCP and OUCUP via E2 interface. Okay, that also connected to ODU via E2 interface. Sorry. Okay, so this is connected. So this is the location of non-real time. Now we will see the real picture of non-real time actually, how it's look like. Okay, and what are the functions we have. So the purpose of near RT rig. So near RT rig has some function. So what are the functions we have? Network RAN intelligence, okay, like policy enforcement, handover management, resource assurance, like radio link control network and the self-optimized network, and the resource control like load balancing and the RAN slicing. Okay, so mostly near RT rig job is to perform the like optimization job, so that we can monitor the KPI and we can fix the network actually. So rather what we are doing right now, we are checking each drop in the site. Okay, how many drop happen to this sector? So whether we put down tilt or we put we can optimize the how we can put the change the parameter so we can improve the drop. So here we have the system that will do by near RT rig. Okay, so near RT rig basically what it will do, it provide the database that stored up to date RAN information, history of the time, okay, as well as configuration related to that cell. Okay, all the things it will collect. Okay, so near RT rig provide machine learning tool that support data pipeline. Okay, also near RT rig provide messaging infrastructure, security function that will help us to better optimize the network. So here we can see general principle for the near RT rig. So near RT rig architecture and internal interface shall be open to support third-party XApp. So what is XApp? So XApp, you can say that application designed to run on near RT rig. It may consist of one or more microservices, and at that point on onboarding, it identify which data it consume and which data it's provide. So it is totally independent on near RT rig and provided by any third party. Okay, so how it's look like that we can see. So near RT rig, important thing is that XApp, security, messaging infrastructure, subscription management, management service, and the conflict mitigation. So this is your architecture of the near RT rig, you can see. So here you can see the upper part is your non-RT rig, and that small one you saw. So this is your complete near RT rig actually. Okay, So NearRT Rig hosts the following function. So what is the function they host? You can see that accept. So we have different accept. So accept perform the enhancement of the RRM, capability of the NearRT Rig, data monitoring, and the parameter function. Okay. Then here we have management services. Okay. So inside the management services, what we can do? We can do the fault management, configuration management, and perform the management as a service producer to the SMO. Okay. Then we have conflict mitigation. Okay. So this conflict mitigation resolve the potential overlapping or conflict request from the multiple accept. Then we have messaging infrastructure. This one enable message interaction among the NearRT Rig internal function. Then we have security system here. So it will provide the security scheme for accept. Okay. And we have interface. So what interface we have here? Here we have E2 termination, which terminate E2 interface from an E2 node. Then we have A1 termination. So A1 means non-RT rig to the RT rig near that one. Then we have O1 interface. So O1 termination which terminate O2 O1 interface from SMO. So these are the interface termination we have. Okay. Now you can see we have different function actually. So the first one that is called accept. So here accept subscription management manage the subscription from different accept to the E2 nodes. Okay, so that we do. Now we have conflict mitigation. So what is this actually? Why we need? So there are three types of conflict. The first conflict that is called direct conflict, and this conflict can be observed directly by conflict mitigation. So here what will happen when you have one or more accept requested different setting for the very same configuration of one or more parameter. Okay, so that time maybe direct conflict will happen. Okay, so here what we have to do, the new request from accept may be conflict with the running configuration. Second thing is that here we have indirect conflict. Indirect conflict means what? The conflict cannot be observed directly. Okay, maybe some of the dependent among the parameter that requested, okay, but we cannot observe. So here we have indirect conflict. And the third one we called implicit conflict. Okay, the conflict cannot be observed directly also. Even the dependency between the accept are not obvious. Okay, so here what we have to do, accept may optimize different metric, reconfigure different parameter. Okay, so that will happen here. Then second one is that messaging infrastructure. So what is messaging infrastructure? So messaging infrastructure provide low latency message delivery service between NearRT Rig internal endpoint. Okay, so it support registration, discovery, and deletion. So registration means what? Endpoint register themselves to the messaging infrastructure. Okay, discovery means what? Endpoint are discovered by the messaging infrastructure initially and register the messaging infrastructure. So this messaging infrastructure provide an API for sending the message to the messaging infrastructure. So it support multiple messaging node like in-to-in point node. Okay, that. Then second, we have the security system. So what is security system? So security basically function given in the sec so that we can apply and we can secure our XApp. Okay, so that no one can tamper. So security requirement you have to follow as per the same 5G NR that we have here. Also we have to perform. Then we have management services. So the management services means what? We have some life cycle for that. So what is that? So the management services means what? Life cycle management of XApp. So here first what we have onboarding XApp. It means it receive and store XApp descriptor that can contain the configuration data of XApp. Second one, we have deployment. It retrieve XApp name and other information. The third one, we have resource management. It does comprehensive resources provisioning control for the XApp on NearRT Rig that can monitor their latency, that can monitor their resource consumption, that can monitor their requirement for the latency. So everything. Okay. And the last one we have that is called termination on XApp. So if you are not running the XApp, so we have to terminate the XApp. Okay, so that resources is why XApp will be released. So we have three. So who will perform? So we can assume that this life cycle management of XApp is performed by SMO. So these are the function that we have to perform actually here. Okay, so now we understand the concept of this part. Now we understand the concept of this one actually, XApp. So XApp means what? You can say that it's a like a software package, okay, that has to perform different jobs. So XApp descriptor provide XApp management services which necessary information for the life cycle management for the XApp. Okay, so we have the different jobs for the XApp, you can see. So that already explained you. Any doubt guys here? I cannot cover all the part here, but I will try to cover. Okay. So this is the except part for that one. Okay, but I think I have to make it more clear diagram for the except so you can understand. So maybe in the next webinar, I will try to cover the except separately. Okay, now we will discuss about NearRT Rig. So what is NearRT Rig? So here, sorry, non-real-time rig, the second one. Here you can see that. So this is connected to the near real-time rig that is called A1 interface. So this is the diagram for the non-RT rig architecture functional view. Okay, so it's a big diagram. So to understand the concept first here, so if you see earlier it was XApp in the near RT rig. Here we have RFs. In short, RF means it application designed to run on non-RT rig. Okay, so basically it's a modular application leverage that functionality exposed by non-RT rig to provide added value services relevant to the intelligence, RAN, optimization, and operation. So we will see here what are the function for that. So non-RT rig means what? So non-RT rig is a function that reside where? Inside the SMO. Okay, that is called service management orchestration framework, and that is direct associate with A1 interface to the near real-time rig. Non-RT rig position is internal so that we can oppose to the interfacing with the SMO, and intended to communicate the non-RT rig is compromised to subset functionality of the SMO itself. Okay, so that the function. So in this diagram, we can see what are the functions we have actually. So here you can see that non-RT rig is divided in 3-4 parts. You can see that. Okay. So what are the parts we have? So non-RT rig first divided in here, here, and here connected. 3 different segment we have here. So non-RT rig framework. So what is this actually? So non-RT rig framework, you can see logically terminate A1 interface to the near RT. This one, this non-RT rig framework. Okay, and here we have different RFs that is exposed via R1 interface, the set of the internal SMO framework services needed to the running time. Okay, so this RFs means what? Non-RT rig application we call. So this RFs means don't get confused. RFs means non-RT rig application. Okay, just, and except means what? Near RT rig application. So this is a modular application that leverages the functionality exposed by non-RT framework. Okay, so why we need it? So here you can see that these are connected to the R1 interface to this up to here and external EI interface. Okay, so now we will see one by one actually what is this framework. So in this diagram you can see that, okay, we have 3 different segment. One is called RFs, another one is called non-RT rig framework, and the third one is called R1. So this is open API for the RFs or non-RT rig internal interface between RFs and non-RT rig. So between these two. Okay, now we can see what are the function. If you see this diagram, non-RT rig framework, okay, so it has some function actually. So what are the function we have here? So the first one that we call modularity. What does it means? It means the functionality of modularize into the set of the services that provide the appropriate granularity level. Okay, the second one that we have extensible. So the architecture allows simple extensible by adding new services and making them discoverable. The third one is called composability. It means we can compose the different services and form the new services. And the third one, fourth one we have that is called discoverability. It means we can discover the new services depend upon the availability of the services. Okay. And the last one we have loose coupling. It means services we can loosely couple and independent from one another. So in this diagram, you can see we have different framework. Okay. So here, if you see what are the framework we have inside. So the framework like AI machine learning monitoring function. So what does it means? It provide online monitoring function to the artificial intelligence machine learning model in the non-RT rig. Like we can adopt contract based strategy for runtime monitoring AI and ML. Okay, then we have AI function, A1 function. Okay, so it's a logical termination policy. Okay, then we have A1 termination. Then we have A1 policy function. Then we have A1 machine learning workflow function, AI machine learning workflow function. So we have different functions that can perform. So in AI machine learning workflow function, we can do the AI machine learning model management function. We can do the AI machine learning data preparation function. We can do the AI machine learning modeling and the training function. We can perform the different function implementation variability function that can flexibly deploy within the non-RT rig and outside non-RT rig, but within the SMO. Outside SMO, we cannot deploy, or maybe if they want in future, they can do also. Okay, so that's the function actually. Then we have RF management function. So what is this RF management function? So RF management function support the interoperability, this one, interoperability between the non-RT rig and SMO, so that non-RT rig and SMO can expose their RF supporting function to each other through SMO services. So that's the function actually they can do. Now here you can see that left side we have different external interface. The first one that we have external AI interface. So this external AI interface support the external sources of AI. Okay, so that we can support the transfer of AI from external source to the non-RT rig that is requested to. Okay, then we have external AI machine learning interface. Okay, so here we can support and we can transfer the trained machine learning model and its metadata from the external AI machine learning server to the SMO and non-RT rig that is requested. Also, with the help of here, we can support the transfer of handshaking messaging between the SMO and non-RT rig and external AI and machine learning server. Okay, so we can transfer the data and we can exchange the AI machine learning servers to the FFS. Then we have external AI machine learning workflow. Then we have human machine interface. Here you can see that. So this interface provided by non-RT Rig for technicians to manually deploy the RAN intent and operate the RFs. Okay, so a human machine interface like a web-based UI. Okay, so here non-RT Rig also provides such function to the technician for their manual operation. Okay, so that we can operate include RAN intent injection. Okay, so these are the functions that we can perform here. So human machine interface, you can put the RAN intent injection, you can check the RF information, you can check the so many things that we have over here. Okay, so these are the interfaces that we have that we can connect and we can do. Okay, so now this is the non-RT Rig architecture function view that we have total. Okay, and here if you see that we have A1 interface. Okay, so A1 interface termination means what? To here O1 that already I explained you. So A1 interface termination means what? A1 interface termination enable the non-RT Rig framework to send and receive the message to and from the near RT rig via A1 interface. So here, if you see, we have different policy. So like A1 policy function, A1 feedback function, A1 enrichment information function, so that we have to perform here. So this is the total uh, non-RT rig architecture function overview. Okay, guys, so that we have. So thank you so much, guys. So I hope it's clear what is non-RT rig and what is a near real RT rig. So if you have any doubt, you can ask me. Sorry for. So now we have the second webinar that will be conducted by Mr. Rahim. So please stay. So 1 minute. Let me check whether he can share his screen or not. Yes. So sir, please join this session. Please share your screen.
Hello, Abhijeet, I can share my screen.
Okay.
Now it's not possible for me to share the screen.
Okay. Let me make a host. I'm a host.
Okay.
Don't go. Stay. Session is not finished yet. Session second webinar is going on. I'm so sorry for my voice and my health is not good, but still I deliver this session.
Yes, I'm connected with two users, but I don't know exactly which of them is admin.
Share, we will see.
Okay, now it's okay now.
Yes, it's okay now.
Okay. So hello again. Thanks again to participate in the webinar. First of all, let me introduce myself. And from this point, I will try to explain 5G system architecture end to end. And maybe some of you know me, and I'm Rahim Navaei, and this is my email address. And you also find me in LinkedIn. This is my LinkedIn ID if you want to check my page. I always try to post to create some posts related to 5G system architecture, 5G NR, 5G, I mean NG RAN and 5G core. And you can check also my posts related to 5G. Okay, from this point, uh, I think many of you have seen the 5G system architecture in some way from LinkedIn, from YouTube, and from some documents from 3GPP specification, and also from some books. And but here in this webinar, I will try to present the 5G system in a different way. but you will see how I present. But I hope you enjoy the way that I present the 5G system. First of all, I prepared a slide related to end-to-end architecture in 5G system.
Can you increase the volume? Your voice is not audible to guys.
Now it's okay?
Yes, voice is very low. They are saying.
Okay,
For me,
if my voice okay, yeah,
now it's
if
okay.
oh, okay, okay. And just let me to check in the chat if my voice is okay. Please write. Okay, thank you, thank you.
Yes, yes, yes. Okay.
Okay, from here, I will try to explain 5G system end-to-end architecture. But as you know, like the previous technologies, I mean 4G, 3G, 2G, we have two parts again, the access network and the core part. But why we are using the access network, you will see, because in the 5G, we are using both the access related to 3GPP and non-3GPP, and both of them will be connected to the 5G core. And we can have one core just can support both the technologies, I mean 3GPP and non-3GPP. Because of that, we are using 5G access network. Okay, so we've got 5G access network, and we will see why we are using again 5G access network. And also we've got 5G core, and finally we will have 5Gs 5G system. So 5G system means 5G access network plus 5G core. But uh, I think you have seen 5G system contain NG-RAN plus 5G core. But here you can see rather than NG-RAN, we are using 5G access network. We can see later why we are using 5G access network. Okay, we've got also data network. It could be internet or IMS. But again, if you remember in the previous technology, we were using PDN, packet data network. But here we are using data network. Why we are not using P packets before DN? I will explain the reason uh, that we are using data network rather than packet data network in 5G system. And this is very important to know for what reason the UE is using 5G system, because UE, first of all, should register with the network. When UE register with the network, it will be possible for UE to get the services from the 5G system, okay? Because 5G system uh, are going to offer or deliver different services to the devices inside the system. So first of all, UE can register with the network. When UE register with the network, it will be possible for UE to get the services from the system. And again, this is very important to know for what reason we are using 5G system. Okay, I register with the network, and after that, I want to send and receive the data, for example, from the internet, from the YouTube. Okay, I'm going to watch a live stream in YouTube. Yeah, 5G AN. Okay, some one written 5G access. Yeah, 5G access net. You will see the abbreviation. So you is going to send and receive the data from internet, for example, YouTube. Okay. So for this case, for this reason, we have to establish a session between UE and the last gateway in the 5G system. But what is the name of the last gateway in the 5G system? The name of the last gateway we can say is UPF, user playing function. Okay, this is the last gateway that can connect you to the data network to send and receive the data. So First of all, okay, so after registration, a PDU session should be established between UE and data network. But if you remember again, in the 4G system, when UE is attaching to the EPS, EPS, Evolved Packet System, or Evolved Packet Core, you are attaching to the Evolved Packet Core, you will get also a default bearer. It means a PDN connection will be established when attaching is accepted by the network. But here in 5G, it is possible to register with the network without any PDN connection. Here, I mean without any session. So, but in the new release of 4G, now it's possible due to machine type communication. Now it's possible for the devices to attach to the network without PDN connection. It is very similar to 5G system now. Okay, so you should consider both of them. I mean, both in 4G and 5G, now it's possible to register with the network without any session, without any connection to the network. So it's possible. But in the first release of 4G, I mean LTE release 8, it was not possible. When UE is attaching to the network, the network will give the UE a default bearer. I mean, a PDN connection is established by the network in 4G system. Now, there is the same scenario both in 5G and 4G system. So, the reason UE is using the 5G system, okay, just to get a PDU session to send and receive the data. Now we have PDU session, okay? But if you remember, in 4G, we were using and we are using packet data network, but here we are using data network. Why? We don't have P before data network, because in 5G, we are going to deliver different services to the UE, to the devices, okay? And all of the services that we are going to deliver the users, just they are not related to IP, internet protocol. They are not related to IP packets, okay? IP just is one of the services we can deliver to the 5G devices, but except IP, we can have Ethernet. You can see just this is animated. You can see rather than IP, okay, we can have also Ethernet. What does it mean? Our 5G system now can act as a layer 2 network, okay? So can send and receive the data is coming from the UE, and just in the when we are using layer 2 network, it means we are using some Ethernet frame to send and receive the data. So it means when we are using Ethernet for PDU, we can have Ethernet PDU session. Now it's possible to send and receive Ethernet frame through our 5G system. Again, we can use also unstructured data. It means we can use non-IP session. Okay, so because of that, we are not using P before DN data network. So you can see we can have IP session, we can have Ethernet session, and we can have unstructured session. But now in the new release of 4G, you can see, you can check, we've got also non-IP EPS bearer. So it's possible in 4G again. So again, they are very similar to each other. So 3 types of session we have here, but also in new release of 4G, we can have 3 types of session again, IP, Ethernet, and non-IP. So just the term is different. In 4G, we are using non-IP, and in 5G, we are using unstructured. So it's very important now. we've I think we got the point why we are using data network rather than packet data network, and why we are using PDU before session, why we are not using just session, because PDU is going to be IP or Ethernet or unstructured. So again, this is very important to know. When the session is IP, there is a network function within the 5G code that is responsible to deliver the IP address, and the IP address will be also, I mean, IPv4 and IPv6. Again, when we are using Ethernet PDU session, who is responsible to give the UE the IP address? Again, IPv4 and IPv6. So there should be an application server or a DHC server outside of our 5G system. Now it's responsible to give or allocate the IP address to the UE. So first of all, we can say UE can be connected to the, I mean, data network through 5G system, and it can get by some protocols the IP address from the data network or DHCP server outside of the 5G system when Ethernet session is used. When we are using unstructured PDU session, again, we need an IP address which will be used by the last gateway user playing function. But there is a mistake here. You can see here, you will see UFP. This is not correct, and it should be corrected. UPF, user playing function. What does it mean? For unstructured and for non-IP PDU session, again, we need an IP address for that UE, but this IP will not be given, I mean, to the device. This IP will be allocated to the UPF or last gateway by one specific network function within the 5G core, but this IP will be used for send and receive the data from the last gateway to the data network, because we need to create a connection, an IP connection, a private IP connection, or we can use as a VPN, for example, between the last gateway and the data network. And for this connection, we need IP. But this IP will not be allocated to the device, just will be used here, because we are going to deliver from this point, I mean the UPF to the 5G device, non-IP packet. This is not IP packet. And we do not need any IP address, I mean the source and the destination IP address for this data pipe. So to send and receive the data from the UE and to the data network, we need a data pipe. We need a logical connection. And the name of this data pipe is protocol data unit session or PDU session. And three different types of PDU session we can have: IP PDU session, Ethernet PDU session, and unstructured PDU session. And as I told you, again, in new release of 4G, we've got also IP, Ethernet, and non-IP. And how this type will be clear for the network, for the 5G system, from where 5G system know which type of PDU session should be allocated to the device. When device is registered with the network, the device can request PDU session establishment. This request can be sent from the 5G device to the 5G network, I mean the 5G
please
core.
loudly? People are saying your voice is not audible.
Now it's okay?
Yes, this is okay actually.
Okay, just okay, no problem. Just yeah, from this point, just I want to say, from where the 5G system knows which type of PDU session should be allocated to the UE. As I told you, first of all, UE can register with the network. After registration, UE can request PDU session establishment. Okay, a PDU session should be in place, should be established between the UE and the UPF. And the type of PDU session, IP, Ethernet, or unstructured as an information element within the PDU session establishment, which is a NAS message, a layer 3 message will be sent through the 5G access network to the 5G core. And there is a network function within the 5G core, which is called SMF, we will see later. And by getting the request, this network function will try to the session that you requested, IP, Ethernet, or unstructured. Okay. Let me explain more about the 5G access network. If you remember, I told you 5G, why we are using 5G access network. Some of you, again, you have seen NG-RAN, next generation radio access network. Okay, but now we are using 5G access network. For what reason, for what purpose we are using 5G access network? We will see here. 5G access network can be divided to the 3GP access network and to non-3GP access network. So because of that, we are using 5G access network. So if you remember, in 4G, we are using 3GP access, okay, and we can connect through 3GP access to the EPC, Evolved Packet Core. But if the UE, okay, UE may work both for 3G and non-3G, but if you want to switch to non-3G, for example, okay, UE can work simultaneously for 3G and non-3G, because if you remember, we can have LTE Wi-Fi aggregation. We can aggregate LTE and Wi-Fi just to increase the throughput. It's possible. But just consider a situation, UE can switch from 3GP access in 4G to non-3GP access. If you switch to non-3GP access, first of all, UE should be authorized and should be registered with the network. But there is, I mean here, evolved packet core is not be used as a core to register, or I mean to authenticate or to authorize the 4G device. There are, for example, some other network function, for example, AAA and evolved PDG, okay, for user plan and for control plan, they are responsible to accept the 4G device to send and receive the data from non-3GPP. So in 4G network, there are two separated, I mean, parts. One of the part is used to accept the U in 3GP access, and one of the part is used to accept U in the non-3GPP. Okay, but now there is a possibility in 5G, just we can say a same core network will be used both for 3GP access and non-3GP access. So it means UE can connect through 3GPP and non-3GPP to a same 5G core. Again, we can find a network function within the 5G core can take the responsibility both for 3GPP and non-3GPP access. It's possible now in 5G. So because of that, we are using 5G access network because it is not related just to 3GP access. It is related, I mean, to 3GP and non-3GPP. But for non-3GP access, we can have both trusted and untrusted non-3GP access. For example, untrusted non-3GP access, we can say through an access point. For example, WLAN, wireless local area network access network. It's possible, okay, to connect to the 5G core. But again, there should be some network function after this access point just to create a connection which should be secure to send and receive the data. Again, in non-3GP access network, we can have TNAN, trusted non-3GP access network. Again, WLAN we can use to be trusted. Okay. And one of the important thing you can see here, we've got also W5G AN, wireline 5G access network. Again, this access network could be considered as a non-3GP access. Okay, so there is a possibility here now to use some 5G devices, and these 5G devices can be connected to the 5G core through W5G access network. So this is possible now. So you can see here, we can have 3GP and non-3GP access. And in this example, in this slide, I will try to use 3GP access, but I think we don't have enough time to explain non-3GP. Maybe in future, I can provide you some other slides related to non-3GP, and I will explain more for non-3GP, trusted, non-trusted, for wireline. Again, for wireline 5G access network, it should be trusted and non-trusted. And now in this webinar, I think we don't have enough time to cover all the slides. So let me to prepare some slides in the next webinar. So from here, from this point, I will try to explain 3GPP access. And you will see here, we can consider 5G access network as a 3GPP. Okay, you will see here, we will have 3GPP access network here. If we consider 3GPP access network, we can consider NG-RAN. 3GPP access network can be called again as an NG-RAN, next generation radio access network. Okay, from this point, we can use NG-RAN rather than 5G access network. And within the NG-RAN, we can have the base stations. Okay, so we can have the base station within the NG-RAN. These base station can have some features, or they can be capable to be connected to the 5G core. So if you find any base station within the NG-RAN, it means they can connect it to the 5G core. So one of the base station we can have in NG-RAN is 5G base station. But what is the name of base station? Is GMB. Okay, this is specified by 3GPP. So GMB is the name of 5G base station. Also, we can have 4G base station. So if we want to use 4G base station within the NG-RAN, it means again 4G base station wants to connect to 5G core. And how it's possible? Here we have to add some capabilities to the 4G base station. It should be enhanced. It should be upgraded. Okay. For what reason? Because we want to connect the 4G base station to the 5G core. So the name of 4G base station can be changed. Again, 3GPP introduced NG GMB. We can say next generation GMB. So we can have two types of base station: 5G base station GMB and 4G base station as the NG GMB. And each of them, okay, each of them can prepare some resources to the 5G device through physical channels. Okay, so between, the UE and the 5G and 4G base station across the air interface, we can have physical channels. So actual transmission will be happening, in physical channel. Through physical channel, it will be possible to send and receive the data. For example, one of the physical channel for data to send and receive, we can say in downlink direction, we are using PDSCH, physical downlink shared channel, same as the physical channel that we are using in 4G, and PUSCH, physical uplink shared channel. Again, the same physical channel that we are using in 4G. Okay. And in 5G, I mean in NG-RAN, we can deploy our 5G and 4G base station in different way. So here we have deployment scenario in NG-RAN. We can deploy our 5G base station or 4G base station as a standalone node. It means they do not need any help from other base station. They can connect to the 5G core separately in SA. So we can also deploy our base station in non-standalone way. What does it mean? It means for example, our base station cannot prepare the device the enough resources. So for example, UE is going to send and receive some data from the data network, and to receive the data from the data network from the YouTube, for example, it needs throughput more than, for example, 10 gigabit per second. And from this point, the 5G device is connected to a SA node, for example, one of the base station. So it means from this point, these bases cannot prepare the throughput that UE needs to receive the data from the internet. And from this point, the base station can send a request to another base station to add this base station, to tell this base station, I need you to prepare extra resources, more resources for the 5G device, because I need your help, and we can work together to prepare the resources, I mean the physical channels, for example, and to send the data that UE is going to receive, and we can prepare and we can provide the throughput that UE again needs to receive the data. So from this point, we can say another base station can be added to our base station, and non-standalone solution concept now is coming. Okay, so we have two solutions for deployments: SA and NSA, non-standalone and standalone and non-standalone. And we will see later and how we can use NSA. So if we've got base stations within the NG-RAN, they can be connected to each other through an interface. The name of this interface is XN. If you remember again, in EUTRAN, the 3GP part of EPS, we are using X2 interface. So here, if two base stations are going to be connected to each other, we can use XN. And from here, you can see we have two lines, solid and dotted lines. Both user plane and control plane will be exchanged between two base stations. Now we can go to see some network function within the 5G core. The first network function we can see in the 5G core is called AMF, Access and Mobility Management Function. Now this node is responsible both for access and also for mobility. Okay. And if you is going to register with the network, which network function within the 5G core is responsible for registration, AMF, Access and Mobility Management Function, is responsible to register the UE. We have also another network function which can work with AMF to authenticate the 5G device. authentication server function. And again, we've got UDM, Unified Data Management, a database of user profiles. Okay, we can have the profiles of the user within the 5G system in UDM. So here we can say AMF with the help of AUSF and UDM can register, can accept the registration request from the UE. You know, first of all, UE should send registration request to the network. And this registration request will be received by AMF. And how it's possible to send this message through NAS, non-access stratum, a layer 3 message. Through NAS, the registration request will be sent to the AMF. And AMF, once gets, the registration request, it can work with AUSF and UDM to authenticate the UE. Again, if you know, both UE and the network can authenticate each other. If you remember in the first, if you remember, if some of you are working with 2G, okay, now there is a possibility in 2G, I will tell you. Just we can say network can authenticate the UE in 2G. But now again, there is a possibility in 2G, in the new release of 2G, there is a possibility both the 2G device and the, the 2G system, both of them can authenticate each other. But in the first release of 2G, there was not possibility for 2G device to authenticate the 2G system. Just 2G system can authenticate the UE. But here in 4G, 3G, in 5G, now there is possibility, a mutual authentication. Both of, 5G, both of the 5G core and the UE can authenticate each other. So we can say 3 network functions within the 5G core are responsible to authenticate the UE: AMF, AUSF, and UDM. And from here, I want to show you some terminology in 5G system. But again, just I forgot to tell you, now we are using network function virtualization concept, NFV. And our network function within the 5G core are virtualized. It means we are using VNF, virtualized network function. And each of the network functions that you see here, they are virtualized network function, VNF. And also, we are using the SDN concept, same as NFV we are using for transport. And with the help of SDN and also NFV, now there is a possibility to create some slices in our 5G system without virtualization. NFV concept and SDN, there is no possibility to create slices within the 5G system. So we have to use NFV and SDN. And with the help of NFV and SDN, now we can easily create logical networks or multiple logical networks, which can be considered as a slice on the top of our physical structure, infrastructure, physical infrastructure. But there is a new concept in 5G core when we are using virtualized network function. You can see here on the top of AMF, you can see this one, and AUSF and UDM. You will see they are connected. AUSF, AMF, and UDM, they are connected through a bus. The term that you are using in computer science. And the name of the interface above the AMF, that is connected to the bus is SBI, Service Based Interface, and it's based on API, Application Program Interface. That's the thing that I think you're familiar, that you have seen in the web client and web server. A web client and web server, when they want to communicate to each other, they are using API. Okay, so we are using this concept in 5G core. It means AMF, AUSF, and UDM, they can connect to each other through SBI, service-based interface. So a new concept you can consider in 5G core as SBA, service-based architecture. It means the network function, the virtualized network function within the 5G core, they can connect to each other through a bus, through a service-based interface with the help of API. It means if AMF is sending a request to the AUSF and AUSF is going to respond to the AMF, they can use API call. I can write here. So using API call, the network function within the 5G core can communicate to each other. But you can see there is a network function which is called NRF, network repository function. If we want to complete, service-based architecture, we have to implement NRF, a new repository function. If you remember, UDM is a network function, can maintain the profile of the users, the devices. NRF is a network function within the 5G core, like UDM is a database, can maintain the profile of the network functions within the 5G core. So it is very important to implement this repository function in the 5G core. Why? Because if you remember, UE is going to send a registration request to the 5G core, and AMF will be responsible for this case, to take the responsibility for registration for that device. If you remember again, first of all, AMF needs to authenticate the UE and needs to communicate with AUSF. And how it's possible? Because AMF doesn't know which AUSF should use to communicate, to authenticate the UE. AMF can send a discovery message to the NRF. Okay, I want to find an appropriate AUSF to authenticate the UE. The request will be sent by AMF to the NRF through SBI interface through the bus using HTTP2 protocol. If you remember, in web client and web server, we are using HTTP version 1 and also version 2. Now the version 2 is used in service-based architecture. Just we are using one protocol to send and receive the data, the signaling info between the network functions using HTTP2. So the request will be sent by AMF to the NRF, and NRF will send back the info that AMF requires. For example, the info related to some AUSFs. Maybe NRF will send the AMF multiple AUSFs. Again, there will be a configuration, I think, in AMF. With the help of this configuration, AMF can select one of the AUSF and can send the request using HTTP protocol, HTTP2 protocol to the AUSF. So it will be possible. So if we have implemented NRF within the 5G core. Now it's possible for all the network function to discover a network function that they are to send a request to it. So it's possible with the help of NRF. Now from this point, you will see AMF is connected to the 5G base station through N2 interface. This is dotted line. It means signaling info will be exchanged between two nodes. And NGAP protocol will use to send and receive the signaling info through N2 interface, both by 5G base station and AMF. Again, also we can have N2 interface between AMF and 4G base station, NG. Just again, there is mistake here. I should correct the mistake. This is not GMB, this is EMB. I mean NG EMB, because this is a 4G base station. Just it should be corrected. NG EMB. And we've got EMB, and EMB should be upgraded, should be enhanced to work within the NG RAN to be connected to the 5G code. So the name is changed from EMB to NG EMB. Okay. So from here, from this point, we want to see some identification that can be maintained by UE, the device. One of the identity is SUPI. But SUPI is very similar to IMSI that you're familiar in previous technology, 4G, 2G, 3G. But if you remember, in 2G, 3G, 4G, if you is going to send an attach request, initial attach request, you has to, for example, to send IMSI through across, the air interface to the MME as a network function in EPS. But here, in 5G, now there is a possibility to do not send the SUPI to the network. Rather than the SUPI, the device can send SUKI, the concealed one. Okay. So again, so your identity will be safe because you're not going to send the SUPI through air interface to the GMB and then from GMB to the AMF. So the concealed one, because the device can hide the identity and then send to the network. And we are using PAY. This is very similar to IMEI, permanent equipment identity. We are using 5G GUTI. And if you remember, in 4G, we were using EPS GUTI. Why we are using both of them, 5G GUTI and EPS GUTI? Because maybe this UE is coming from EPS. It's changing the system from EPS to the 5G system. And if UE is going to send the registration request to the 5G system, UE can use the 4G GUTI and can map it to the 5G, for example, GUTI, and send to the 5GS, 5G system. And also UE also can be configured for a slice selection. So we can also maintain network slice selection assistant information. It is a collection of single network slice selection assistant information. For example, a device can be connected to a data network for enhanced mobile broadband. For example, again, can be connected to data network, can be used for massive IoT, and can be connected to a data network which is responsible for ultra reliable low latency communication for this device. But again, we can see later, we can have multiple slices just related to enhanced mobile broadband. 100,000 slices, for example, related to just enhanced mobile broadband. It's possible. There is possibility in 5G, but it is trade-off. You should think about that. How many slices you have to create in 5G system. Okay, if you remember, to send and receive the data from UE to the data network, we need to establish a PDU session. And this PDU session will be placed between the UE and the last gateway, UPF. From this one, you can see here from UPF to the data network, we've got N6 interface, and you will see also PSA for this UPF. What does it mean? Because if UE is moving around the network, we want to have one of the UPF as an anchor. And this UPF is connected to data network, can be considered as anchor for this device, for the PDU session of this device. Because of that, we are using PDU session anchor UPF. If we are going to establish a PDU session, some other network function we have to implement in 5G core, or we have to use them. If a request is sent by UE to the 5G core, first of all, AMF will receive the request. Which request? PDU session establishment request, which is a NAS session management request. AMF is access and mobility management function, and this network function is responsible to handle the NAS messages related to mobility management. So we can have two types of NAS messages: mobility management and session management. For PDU session establishment, which is a NAS message again related to PDU session, AMF is not responsible to handle this message. Which network function within the 5G core is responsible to handle this message? SMF, session management function, is responsible to create a PDU session, for example, IP session, and is responsible to allocate an IP address to the UE when receive the request from the UE. So AMF will act as a proxy for this NAS session management request. It means it will get this message and will send to the SMF again through the bus, okay, using HTTP2 protocol. But before to sending this message to SMF, an appropriate, SMF should be selected by the AMF. And how it's possible? Again, with the help of NRF, AMF can discover, and NRF can send back the info that AMF requested. Multiple session management functions, and again, AMF can select one of them and can send the request to the SMF. You will see here PCF, policy control function. Okay, so we need some policy both for access and for session. If UE is going to be accepted for registration request, some policy related to access and mobility should be sent to the UE and should be maintained, should be saved in AMF. And how it's possible? AMF can communicate directly to the PCF, can get the info related to access and mobility, and then can accept, okay, because AMF first of all authenticated the UE, and also from here AMF can get some info related to access and mobility, and also AMF can interact again with the UDM, okay, to run some procedures, and finally AMF can accept the registration request and some policy related to access and mobility that AMF got from the PCF can be sent to the UE. But for PDU session establishment, again, we need some policy related to session. Again, SMF should interact with a PCF, and PCF will send back the info that SMF requested. And session management function when gets some info related to policy, and also SMF can interact, can communicate, with UDM to get the profiles of the UE, and then can communicate to the PCF. Finally, we can say SMF can communicate to the UPF, to different UPFs to create the PDU sessions. And also SMF can send some info related to PDU session to the GMB and also to the device. And it means the info for PDU session will be distributed by session management function to different nodes. To the UPF, to the 5G base station, and to the 5G device. You will see here also NEF, network exposure function. What does it mean, NEF? What does it mean? Because we can say here, our 5G system got some capabilities. These capabilities, okay, we are going to expose to the third party outside of the 5G system, for example. And who is responsible to expose these capabilities? Network exposure function can expose our capabilities. There are some different examples. Now we don't have enough time. Maybe later we can focus on specific, just on NEF, network exposure function, and to explain how it's possible for the network function within the 5G core, that they have some capabilities to send these capabilities to outside of the 5G system with the help of NEF. Then you can see here, within the data network, we can have application function. This is APF1, and this is AF1 and AF2, application function 1 and application function 2. Okay, but some of these application functions can be trusted and some of them cannot be trusted. Some of them can be located in the trusted domain of the 5G system, and some of them, they are not located in our trusted domain. I'm going to give you an example, a specific example. From here, you can see if the application function is trusted or is located in our trusted domain, can communicate with PCF directly through N7 interface. I can give you an example. If you are going to establish, if you're going to establish a PDU session related to, voice over NR, okay? Yeah, first of all, you can create the PDU session, but I should show you some of the definition related to quality of service flow. If you are going to create some quality of service flow related to voice over NR, a network function within the IMF as a proxy call session control function, as an application function, should communicate to the PCF to send some info to the PCF, and PCF can send this info to the session management function. So they can communicate to each other through N7 interface. But for some of the, application function, they are not located in our trusted domain. If they are going to communicate or to send and receive some data within the 5G core or 5G system, they have to, first of all, they have to send the data to the NEF. NEF can act here as a proxy, should authenticate, should authorize this application function. And then it can send the data to the right network function within the 5G core. And again, in the new release of, 4G from release 12 onward, okay, we are using a SCIF. Someone asked me, okay, yeah, again, exactly. NEF is similar to SCIF in 4G, yes. Service capability exposure function, when we are going to, when we are adding some capabilities related to massive, not massive, machine type communication, enhanced machine type communication in 4G. Now we can add a SCIF to the 4G system. And again, if you remember, we can have EPS bearer in 4G system, for IP, for Ethernet, and for non-IP. And we can create a EPS bearer related to non-IP, because we can use our IoT devices, Internet of Things devices in our 4G system, and we want to send some packets, okay? Just we are not going to increase the size of the packet. If we remove, for example, the source and the destination IP address, we can decrease the size, okay? So from this point, we need to send and receive some data can be considered as a non-IP data. So we can also create a session in 4G system, like in 4G, 5G, related to non-IP. If you remember, in 5G system, we are using unstructured P2 session, but in 4G, we are using non-IP. So the application function, for example, some application function within the data network, they are responsible to send and receive some data to IoT devices, but they want to send non-IP data, for example. They can send the data in 4G system to the SCIF, and SCIF then can communicate to the network function within the EPS, and finally can send the data to the UE, okay? So NEF is very similar to the SCIF in 4G. Okay, so now we can say why we are showing, AF1 and AF2, because some of the important info should be sent through, by the application functions to our 5G system. For example, which node is responsible, for example, to get this info? But many of the nodes, network function within the 5G can receive the data. But one of the network function within the 5G core that can get this info is PCF. If we want to, for example, to create a PDU session and to create some quality of service within the PDU session, we want to change, for example, dynamically some info related to the session and quality of service. These application function can interact with our 5G system and finally to the PCF directly or through network exposure function, for example, and can send some important info related to the PCF. And then when SMF communicate to the PCF to get the policy related to the session, PCF will send the data related to the session, the policy, PCC rules to the SMF, and SMF can send this data to the multiple user plane functions. But from this point, from here, we can say in the data path of the UE, from the UE, to the data network, we can have multiple user plane functions. You can see here, SMF can communicate here from this example to two, UPFs. One of the UPF, you remember, we called PSA, PDU session anchor UPF. And one of the, the UPF can call intermediate UPF. Why? We are using two types of UPF. For example, for this example, our UE is connected to the 5G base station, and we are not allowed, for example, to connect our 5G base station directly, to the data network with the help of, intermediate UPF. Now it's possible to create a data path, okay? So we will have intermediate UPF and PSA UPF, but we've got here an interface which is called N9 between two UPFs. And we also have N3 interface between our 5G base station, 4G base station, N3. Now, if we are going to send and receive the data, UE, first of all, for example, in uplink direction, UE can send the data through air interface with the help of physical channels and data radio bearer to the 5G base station, and then 5G base station can send the data through a GPRS tunnel, entry GPRS tunnel to the UPF, and also between two UPF we can use also GPRS tunnel. The things that you remember that we are using in 2G, 3G, 4G. Now we are using also, in 5G system. So now we've got all the interfaces. The air interface, 5G and UU interface, N3 interface, and N9 interface. And we also created our PDU session. Just remember, this PDU session can be related, to the IP, Ethernet, and unstructured. From here, we can consider as an IP session, SMF, session management function, with the help of PCF, UDM, okay, can send the info related to the session, for example, call of service profiles, call of service roles, packet detection roles, okay. This info should be sent to the UPF, to the 5G base station, and finally to the device. And we can say all the info related to the session will be distributed by the SMF to the nodes within the 5G system. So I can give you an example. For example, we are going to send and receive the data related to our VoNR, voice over new radio. We created our PDU session. This PDU session, it means we got an IP address, and this IP address will be used for our device to send and receive to the IMS for signaling point of view, okay? Because if UE is going to request, or to create a pipe for voice over NR, it has to create a quality of service flow. For this case, a signaling info, SIP, session information protocol, should be sent to the proxy call session control function within the IMS. Okay, and then how it's possible? It means we have to create a quality of service flow within the PDU session. And we can see here, for this quality of service, we are using an identity, an identifier. We can give an identity to this quality of service flow. For example, QFI1, QS flow identifier. And we can have multiple quality of service flow within the PDU session. If you refer to the 3GPP specification, 38.413 and 38.133, you can find the quality of service flow identifier from 0 to 63, 64 quality of service flow. Okay, you can see. Sorry, just wait a second, I disconnected. Okay. And we can also have another quality of service flow. If you remember, to create a voice over NR, we have to send and receive some signal info related to VONR. Okay, so we can first of all we can create a QoS flow related to the SIP, session information protocol. And also, when signaling exchanged between the UE and the IMS, another pipe, another quality of service flow can be created for that device. Here you can see QFI2. Like 4G, if you remember, we have default EPS bearer and we have dedicated EPS bearer within the PDN connection. If you know in 4G, first we can create a PDN connection, okay? But if you remember, but during attach procedure, both PDN connection and also attach procedure can happen simultaneously. It's possible. It means when UE attach to network, UE can get also a PDN connection. But these PDN connection, within the PDN connection, we can have a default EPS bearer. Now, someone asked me, my voice is not okay. If my voice is okay, please write something in chat message. Okay, now it's okay. Okay, so from here we can see we have two quality of service flow within the PDU session. One of the quality of service flow can be considered as a default QoS flow, and one of the QoS flow can be considered as a dedicated QoS flow. Okay, but for both of them, we can allocate an identity QFI1 for default and QFI2 for dedicated. But we have to separate, we have to differentiate these two quality of service flows. But for this example, we are using two quality of service flows. But maybe for some devices, we can create, for example, more than 5 quality of service flows possible. But this is an example. In this example, we are creating just two quality of service flows, okay, 1 and 2. And to differentiate these two quality of service flow, I mean to differentiate the IP flow that are coming from the data network, that they are we want to send these IP flows to the device, we have to put to different quality of service flow. And how it's possible? Again, UPF, by getting some rules from the SMF, can differentiate the IP flows that are coming from a data network or different data network, and it can send the IP flows in a different quality of service flow. So for each quality of service flow, we can have 5 QI. I mean 5G quality of service identifier. Okay, and you can see 5 QI5. This is a value that is used for default for IMS signaling. This is same also in 5G. We are using 5QI1. If you remember, we are using QCI, okay, in 4G. Now we are using 5QI. So QCI is using for EPS, but now 5QI is using for quality of service flow. And you can see here 5QI1. Again, this is a value that is used for a dedicated quality service flow, for example, for voice over NR, for conversational cases, okay? But each of these value, we can refer to a table. We can see which parameters we can find for these two specific values, okay? Again, you can refer to the spec. I mean, to 3GP specification. I mean, here, I can write here 23501. Okay, you can refer to this specification and you can find a table related to 5QI and you will find the parameters. We can differentiate, I mean, the IP flows that they are coming from multiple data network with the help of quality of service flow. Okay, so granularity of the quality of service flow will be done with the help of kiosk flow. If you remember, this granularity in 4G will be, I mean, in 4G with the help, I think in 4G with the help of EPS, we can differentiate the quality of service flow. Okay, so here the granularity in 5G we can implement, okay, I mean to differentiate the quality of service flow with the help of 5QI and also Q's flow. So there is a table here I will show you. I don't know it's clear for you. Can you see the table under the previous session? Just, I mean, there is an icon, stop sharing. Now it's possible. Now it's possible for you to see the table. Can you see the table under the previous session? Okay, I hide. Now it's possible. Thank you. Now it's okay. Okay, thank you. Okay, so we can consider all services as a guaranteed bitrate, non-guaranteed bitrate. The two types, you know, you have seen in 4G, but we also have another resource type in 5G, which is called delay critical guaranteed bitrate. Okay, these are the resource types that we are using in 5G. Okay, for example, 5QA1, this is used for GBR guaranteed bitrate. If you remember voice over NR, this is guaranteed bitrate service, so it's clear. And 5 is considered as a non-GBR, a signaling that is exchanged between you and the IMS. Okay, this is non-guaranteed bitrate, so there is no, we don't need to guarantee, guarantee to the rate between UE and the IMS. And you can see another parameter, packet error rate. Okay, also the priority we can consider for each 5QI and some other parameters. And finally, you can see for what purpose we are using. This is an example. We are using 5QI, for example, 1, 5, and 86. For example, 1 is used for conversational voice, and 5 is used for IMS signaling, and finally 86 is used for V2X, I mean message. So now we want to check how it's possible to carry our quality of service flow and how it's possible to send and receive the quality of service flow. Okay, so first of all, you should know, for example, just you can consider here, you can remove one of the UPF, I mean intermediate UPF. Just you can consider a PSA UPF. We've got one UPF and our 5G base station is connected to the UPF through N3 interface. So between I mean 5G base station and the UPF, we got N3 interface. An N3 tunnel should be created for a specific PDU session. It means each PDU session can have just one N3 GPRS tunnel. And for this tunnel, we need tunnel endpoint identity for uplink, both for uplink and downlink, and how it's possible again when UE, I mean during PDU session establishment, this info tunnel ID identifier in uplink and downlink direction will be exchanged and will be received by, I mean, 5G basis station and also the UPF, because if 5G basis station is going to send the data to the data network, it needs uplink tunnel ID. If UPF is going to send the data to the UE in downlink direction, it needs a downlink tunnel ID. Okay, so this tunnel ID should be received by UPF and the 5G base station. The uplink should be received by 5G base station, and the downlink tunnel ID should be received by the UPF. So we can say we've got here two quality of service flows. These two quality of service flows can be exchanged using entry, I mean GPRS tunnel. But when they are receiving, I mean the quality of service flow will be received by base station and should be sent to the UE. Between the 5G base station and the UE in the air interface, we've got data radio bearer. But here just I'm using two data radio bearer, but there's a possibility, okay, to map, I mean, two quality of service flow to just one data radio bearer. Again, it depends to the configuration in the GMB, okay? So, and also, if you remember, session management function will send some info related to session, for example, QoS profile. The QoS profile for each QoS flow will be sent by the SMF to the GMB. And we also have some configuration related to the session in 5G base station. And 5G base station, with the help of this info, can decide, okay, how to map the quality of service flow that are coming from entry interface to the data radio bearer, to the one or to the multiple. Okay, so for this example, each quality of service flow will be mapped to a specific, I mean, DRB. So we have two DRB. One of the DRB will be used for the default one. We can consider this DRB as a default DRB, data radio bearer, and the another one will be used for the dedicated quality of service flow. So we can consider this DRB as a dedicated DRB. So again, if you refer, I mean, to the 3GPP specification 38.1, I mean 331, okay, you can see the DRB numbers from 0 to 31, 33, 32, okay, DRB number you can see. But again, when you see again exactly, when you go in very detail in 3GPP specification 38.331, again you will see just 29 of these DRBs can be used, okay, in the air interface. So we can have multiple quality of service flows, and we can have multiple data radio bearer in the air interface for a PDU session. And how the mapping will be done for the QoS flow to the data radio bearer, it depends to the configuration of the 5G basis session and the session info that received from the session management function. Okay, now just I think just I can ask the administrator how much time we have, okay, to continue, and I can continue some other slides. Abhijeet, are you here?
Yes, yes, sir, I'm here.
And
Hello.
Yeah, how much time I have?
Almost I finished.
Okay, just I've got some other slides, but maybe, you know, just I try to explain. I mean,
we can do for the next webinar, because almost 2.5 hours already passed. We can keep this for the next month webinar. this topic.
Okay, yeah, I've got, just as I told you, I tried to explain a 5G system in end-to-end architecture. Okay, so
Yeah.
I hope you enjoy my way for presentation. If you remember with my post in LinkedIn, always I'm going to create a post for 5G system. I mean, as a big picture. Okay, now we can consider this slide as a big picture, and I hope I uh, gave you some info related to 5G system. Okay, but maybe we will have some extra time in the next webinar to, I mean, to present some other slides related to 5G system. But I prepare some slides related to dual connectivity and also slicing. Now we don't have enough time. Sorry for that.
Yes.
Okay, thank
So good.
you all of you again to
Guys,
participate in the
also
webinar.
we present 4 courses, two courses will be presented by Mr. Rahim, already shared in the chat message, and also we will email you regarding the 5G in our system and the 5G in our architecture. And one course is I present that is for the ORAN in the depth, almost 8-hour course, and another one is that 5G RICS and optimization. So if you are interested, you can go through that, and you can ping us in the LinkedIn to ask about the Q&A. Okay, so that the things.
Just one more thing. I want to say something to all of you that you are participating in the webinar. Just always I create some posts related to 5G. But if you see my last post in LinkedIn, it's related to, I mean, 5G and R related somehow to the physical layer. But this is very, uh, just we can say there are many people in the LinkedIn, just they can see, okay, they can see the post, and just they do not focus on the post, okay. But I think this is related to those people, but they don't care. But I want you, okay, if you are interested to some posts related to physical layer or to 5G system end-to-end architecture, to refer my post in LinkedIn. If you have any question again, you can send me your question through direct, and I also gave you my email address. Okay, also you can your question through my email address, and I will be sure I will respond to your question. Okay, thank you, thank you.
Thank you so much, guys. Thanks a lot. Sorry for the trouble last week. We couldn't completed the webinar. Hopefully, we will have good webinar next month. Take care. Bye bye. Soon we will upload this video on YouTube channel. Okay, so please wait. Please, the person who joined the session, we will try to give the webinar certificate. So those who joined fully, so those person, I think they will get the certificates. So, but don't be patient. Most probably the certificate we will provide you end of the mid of the month or end of the month, or if because I'm not well, so I will try to provide you end of the month. Thank you so much. Thanks a lot. Bye bye. Take care and be safe.